This is the lesson for February 19th, Parallelograms and Quadrilaterals. Our first question is, what is a quadrilateral? And hopefully all of you know what that is. That's right, it's a four-sided figure. Now let's think about what a quadrilateral can look like. It doesn't have to be anything special, it just has to have four sides. So all of these are examples of quadrilaterals. Now, what's a parallelogram? It's still a four-sided figure, but there's something special about a parallelogram. Most of you probably draw a parallelogram that looks like that. All a parallelogram is a quadrilateral that has two pairs of opposite sides parallel. So on your handout, you have this picture of a parallelogram, and we're going to use this for several questions today. First of all, how do we know our ABCD is a parallelogram? Let's check the slopes of AB, BC, CD, and DA to see if any of them are equal. It looks like they are. Are any of them perpendicular? Well, let's go and look at our slopes. It appears that they're not because I don't see any opposite reciprocals. Let's go ahead and check the slopes. So when we look at the slope for AB, we get 0. DC is 0, and as we count the slope for BC and DA, we get up 5/1, so those slopes are 5/1. That's where we have our parallel sides. Our opposite sides both have the same slope, so since they have the same slope, our opposite sides are parallel, making this figure a parallelogram. That's the definition of a parallelogram. Two pair of opposite sides parallel. And this is the shape we're working with today. So go ahead and measure in the sides of our parallelogram. As you can see, AB is done for you. It's 11. Measure the other three sides. Go ahead and hit pause here while you measure. Take about 2 minutes to measure these. Alright, now that you have resumed the video, let's fill in the blanks for the lengths of those sides. We should find the sides to be 11, 16.3, 11, and 16.3. Or something close to that. If you're off a little bit, it's fine. So writing in the lengths of the sides. What do we notice about our sides? Let's keep that in mind for an upcoming question. Now let's draw on the diagonals and measure them. Hit pause here while you draw on the diagonals with your geometry template and measure them, please, in centimeters. Take about 2 minutes to do this and then hit resume. Alright, now that you've drawn in the diagonals and measured them, let's take a look at the answers. For AC, I got approximately 17.2 centimeters, and for BD, approximately 21.6. You should have something fairly close to those. And there's where our diagonals are in the picture. Now we're going to measure angles. Use your geometry template, the protractor piece, to measure the angles. Remember to line up the vertex with the angle with the center point on your protractor, and make sure you're getting an acute angle measure for the acute angles and an obtuse angle measure for the obtuse angles. Since there is 2 rows of numbers on the picture, it should be fairly obvious which ones are acute and which ones are obtuse. Take about 2 or 3 minutes to measure these angles and hit resume when you're finished. Alright, now that you've measured the angles, hopefully you've written them in on the pictures. Let's take a look and see what the answers are. So as I'm measuring my angles, I found my angles to be 78, 102, 78, and 102. So I'm going to go back and fill those into the blanks. That's an interesting pattern. Let's keep that in mind for an upcoming question. Now we want to measure some segments in our picture. The point where the diagonals intersect. Let's call that point E. And let's measure the segments that are formed with the vertices and point E. Take about 2 minutes to measure these and then hit resume. Okay, now that you've measured your segments, let's check the measurements. You should have something fairly close to the answers that I came up with. And there's an interesting pattern here as well that we'll take a look at in an upcoming question. All right, there's the segments drawn in. On to the next question. We're going to start thinking about the patterns that we were noticing. Look back to the sides and the measurements of the sides. How would you describe the length of segment AB compared to the length of segment DC? Go ahead and fill in your blank. Hopefully you notice that those two are equal. How would you consider the length or compare the length of AD to segment BC? They should be equal as well. But how about AB to the side next to it, the consecutive side, side BC? Those are not equal. So which sides in the parallelogram are equal? That's what we need to think about as we make our conjecture. How would we describe the sides that are equal? Hopefully you're thinking this as your conjecture. The opposite sides of a parallelogram are congruent. And that's one of the properties of a parallelogram as well. The opposite sides of a parallelogram are congruent or equal. Go ahead and hit pause if you need more time to copy down that slide, and then hit resume when you're ready for the next question. All right, now that we've done one example, let's see if you can fill in the answers for these. Hit pause while you write in your answers. Take about 2 minutes, and then hit resume when you're ready to check your answers. All right, for segment AC and segment BD, we should notice that they are not equal. Part 2, the length of segment AE is not equal to the length of segment BE. Part 3, segment AE is equal to the length of segment EC. Now, if you're off by 1/10 or 100th, that's okay, but you can see fairly well that without measuring error, those two should be equal. And the length of segment BE is equal to the length of segment DE. So which pieces were equal? Let's take a look at those. How could we describe them? Well, the diagonals were not equal, as we can tell, because these were the diagonals in our first sentence, and they were not equal. AE and BE were parts of the diagonals that weren't equal. But when we get down to this piece, those are equal to each other. And those are the halves of the diagonals. So that looks like those diagonals are meeting at the same point. It looks like they're meeting at a midpoint. They have a common midpoint. So as we look at our conjecture, that means that those diagonals are meeting at a common midpoint. Or another way to say that is that they're bisecting each other. This is a really important concept for all parallelograms. The diagonals of a parallelogram bisect each other. Go ahead and hit pause if you need a little more time to write this into your note sheet. Hit resume when you're ready for the next conjecture. Okay, let's take a look at the next set of questions. Hit pause as you fill in the blanks for the measurements of those angles. Take 2 or 3 minutes to fill in those blanks, and then hit resume when you're ready to see the answers. All right, now that you've finished filling in the angle measures, let's see what you've filled into the blanks. Angle DAB and angle ABC. Their angles aren't equal. What do we notice about their measures? We have 102 and 78. Those add up to 180, so we can say that those are supplementary. Let's take a look at the next pair. Angle ABC is 72, Angle BCD was 108, or was that 78 and 102? I think that was the answer, 78 and 102. Anyway, when we add them up, we get 180. So those are supplementary. Let's see what happens with the next set. Angle BCD and angle CDA. When we add those together, we also get 180. So those are supplementary. Very interesting. Let's see what happens with the next set. Angle DAB and angle BCD. We're not looking at angles that are next to each other now. We're looking, or that are consecutive one after the other. We're looking at angles that are across from each other or opposite each other. They don't add up to 180, but what do you notice about their measures? They're both the same, so they're equal to each other. Let's take a look at angle B for angle ABC and angle CDA. They're also opposite each other, and they are also equal to each other. So this leads us to some interesting thoughts. Take a moment and hit pause here to see if you can figure out what goes in the blank. The first conjecture, consecutive angles. What was true about consecutive angles? Those are the ones that are like one after the other, like angle A and angle B and angle C and angle D. What was their relationship? Hopefully you notice that angles in a parallelogram, if they're consecutive, are supplementary. This is one of our main properties of a parallelogram. And it has to do with the fact that we're looking at parallel lines like we did back in Unit 2. These would be considered our consecutive interior angles when we had parallel lines. Now our next conjecture is about those last pairs of angles that we looked at. If we take a look back, what was happening with our last pairs of angles? How did we describe the location from angle DAB and angle BCD? They're across from each other, and in geometry, that can mean opposite. So our conjecture here will be opposite angles in a parallelogram are equal or congruent. Take a moment and make sure you have those blanks filled in. If you need to hit pause, go ahead. All right, last question I want to ask you about our shape. Take a look at angle DAC and angle C or ACB. These are angles that were formed with the diagonal and a side. Go ahead and measure them if you want to. Hit pause if you want a few minutes to take a look at their measurements, or maybe predict what you think is going to be true about them. But let's figure out, take a guess at what you think. Make a conjecture. What do you think is true? Hit resume when you're ready to see the answer. Okay, now that you've had a chance to think about the answer to this question, what did you discover? If we take a look at those angles, hopefully you saw that they were equal. Now, why is it that those angles are equal? Well, if you look at segment DA and segment CB, we notice that those are parts of parallel lines. And we could think of segment AC as a transversal, like back in Unit 2. So what we actually have here is alternate interior angles. So that old stuff from Unit 2 is going to be very, very useful this semester as well. So the reason they're congruent is that they're alternate interior angles formed by parallel lines. Keep that in mind as we proceed with some examples. Hit pause if you need some time to fill that in. Otherwise, let's continue on to the next part. All right, here you see some examples based on the properties that we just went over. Hit pause, take maybe 5 minutes or so to fill these in. If you need a little more time, that's fine. This is our last part of the lesson today before your homework. Feel free to write on your picture to help you find the answers. Hit resume when you're ready to see the answers and see how they're worked out. Okay, now that you've had time to work these problems, let's take a look at them one by one. Number 7, we're looking at angle MJK. I think it's very useful to trace over that angle. So we have angle MJK. We want to find out how large it is. So that's an angle of our parallelogram. What else do we know in this picture? Do we have any measurements for angles in the picture? Well, I see a 30 and a 70, and those degrees, that angle's opposite angle J. Well, we talked about a property for opposite angles in a parallelogram, and we said that opposite angles are equal. So angle L is the opposite angle to our angle J. It is 100 degrees, so our angle J should be 100 degrees. So we get 100 for that measure of angle MJK. Let's go on to the next problem. Angle JML. That's also an angle of our parallelogram. We just found out that angle L was 100 degrees. This one is not opposite angle L, it's consecutive or next to angle L. So how big would it be? What was our property about the consecutive angles? If you need to, look back in your notes. We said that they were supplementary, so if angle L is 100, then 100 from 180 should leave us with 80 for angle JML. Let's go on to number 9. Angle JKL. I think it makes so much more sense to trace the angle on your picture so that you can see it, otherwise it gets confusing a bit with all the letters. Here we have another angle in our parallelogram. We could work it out several different ways. We could think of it as consecutive to angle L, so they would add to 180. We could think of it as opposite to angle M, which was 80, which to me seems a little bit quicker. So we know the opposite angles are equal, so angle K should also be, or angle JKL should be 80. Let's move on to number 10. Angle KJL. This is like the last question I was asking you before we move to the examples. This one is not an actual angle of the parallelogram, but it's an angle formed by the side of the parallelogram and a transversal. So think about it this way, and think back to Unit 2. We have our alternate interior angles, so our angle KJL should be 30 degrees. All right, now let's look at A for number 11. A is a side of the parallelogram. We're not looking at an angle this time, or it's part of a side. It's part of side JM. We know our property for parallelograms, so that say those are parallel, but parallel doesn't really help us with that variable. We also know that the opposite sides of a parallelogram are equal. So JM should be equal to segment KL. So we should write our equation. 3A is equal to 21. Solving it, we get A equals 7. All right, last example. B. B is part of segment JK. Just as in the last problem, we remember our property that the opposite sides are equal, and so that should be equal to ML, which is 45. Let's write our equation showing that they are equal, and then solve the equation. B will be 21. Your homework problems will be very similar. They increase a little bit in challenge as you work through them, but keep referring back to the examples that we did and to the properties that we had. Tomorrow we'll put these on an organizer. Go ahead and begin your homework.